In 1943, American soldiers faced a deadly problem that no war manual had adequately prepared them for. This problem was how to quickly clear rooms filled with entrenched enemies without becoming easy targets at the entrance. The answer came from a seemingly simple weapon, nicknamed Pineapple, due to its characteristic grooves. This weapon would forever revolutionize urban combat tactics. The deafening roar of explosions echoed through the narrow corridors of German bunkers. Metal fragments cut through the air like deadly rain, transforming confined spaces into instant elimination chambers. The Mk2 grenade, officially adopted by the American Army in 1918, carried a lethal promise. It contained 2 ounces of TNT encased in segmented cast iron, capable of producing devastating fragmentation within a 30-yard radius. However, it was during World War II that this weapon revealed its true potential as the most effective room-clearing tool ever developed. What made the Pineapple so special was not just its iconic grooves or its explosive power. It was a precise combination of timing, controlled fragmentation, and combat psychology that would transform ordinary soldiers into urban warfare specialists. The truth behind its effectiveness went far beyond what military manuals revealed. It involved accidental discoveries, improvised battlefield adaptations, and a growing understanding of how psychological terror could be weaponized through a simple sphere of metal. Sergeant James Mitchell held the Mk2 grenade in his trembling hands, observing the deep grooves that gave the weapon its distinctive pineapple appearance. It was December 1944, and his unit was about to assault a complex of German bunkers in the Hürtgen forest. What Mitchell did not know was that he was holding the result of decades of armament evolution. This weapon had originally been designed for open battlefields, but it would prove devastatingly effective in confined spaces. The grooves of the Mk2 were not merely decorative or functional for better grip, as many soldiers believed. They represented careful engineering designed to control the grenade's fragmentation when it exploded. Cast iron, when subjected to the explosive pressure of 2 ounces of TNT, fragmented along these predetermined lines of weakness. This created approximately 1,000 lethal fragments that spread in all directions at speeds exceeding 3,000 feet per second. During the early years of the war, American commanders observed a disturbing pattern. Soldiers died in disproportionate numbers when trying to clear bunkers and fortified buildings. Conventional frontal assault tactics resulted in catastrophic casualties. Especially when facing well-entrenched German positions, the need for a quick and effective solution to neutralize enemy-filled rooms became an urgent strategic priority. It was then that field officers began experimenting with the use of the Mk2 in ways not foreseen in official manuals. Instead of using it as an open-area weapon, veteran soldiers discovered that the grenade was devastatingly effective when detonated in enclosed spaces. There, fragments ricocheted off walls, creating a lethal multiplying effect that transformed any room into an instant death chamber. Lieutenant Robert Hayes watched his men prepare for the assault on the German bunker. This concrete structure had resisted 3 previous capture attempts. The human cost had been terrible. 23 soldiers killed and 41 wounded in just 2 weeks of frustrated attempts. Hayes knew he needed a different approach. He needed something that could neutralize the German defenders without exposing his men to the deadly crossfire waiting at the narrow bunker entrance. The revolutionary discovery came through careful observation and battlefield experimentation. Veteran soldiers noticed that when an Mk2 exploded inside a confined space, the fragments not only hit direct targets, but ricocheted off concrete and metal walls. This created secondary fragmentation patterns that literally covered every cubic inch of the interior space. This pinball effect transformed the grenade from a directional fragmentation weapon into a total area saturation system. The Mk2's fuse mechanism provided a crucial tactical advantage. It offered a 4 to 5 second delay between the release of the safety lever and detonation. This timing allowed trained soldiers to precisely calculate when the grenade would explode. This enabled perfect coordination between the grenade launch and the subsequent assault. Experienced soldiers learned to cook the grenade, holding it for 2 to 3 seconds after activating the fuse before throwing it. This drastically reduced the time enemies had to react or return the grenade. The psychological effectiveness of the Mk2 was as important as its physical destructive capability. The characteristic sound of the safety lever being released, followed by the hiss of the burning fuse, created immediate psychological terror among enemy defenders. Veteran German soldiers later reported that the sound of an activated Mk2 grenade inside a bunker was enough to break the morale of entire units, even before the explosion occurred. Corporal Anthony Rossi pressed himself against the cold concrete wall, listening to the desperate German shouts coming from inside the bunker. His Mk2 grenade had detonated just seconds before. The sudden silence that followed spoke volumes about the weapon's devastating effectiveness. Rossi had learned through brutal experience that timing was everything. Too early and the enemy could return the grenade. Too late and his own men could be caught in the explosion. The lethal mathematics of the Mk2 in confined spaces was simple and terrible. In a typical bunker room, measuring approximately 12 by 15 feet, a single grenade produced a fragmentation density of approximately 5 to 7 lethal fragments per square foot. Considering that only 3 to 4 fragments were enough to incapacitate or kill a soldier, saturation was complete and inevitable. There was no adequate cover, no escape, no survival. Field commanders quickly recognized that the Mk2 was not just a weapon, but a tactical transformation tool. It allowed small units to neutralize fortified positions that previously required heavy artillery or large-scale coordinated attacks. A single grenade, costing approximately $2.50 to produce, could eliminate a defensive position that had cost thousands of dollars and weeks of work to build. Official training began to incorporate specific Mk2 room clearing techniques. Soldiers learned to identify ideal ricochet angles, calculate detonation times for maximum effectiveness, and coordinate team movements to capitalize immediately after the explosion. Field Manual 2330 was revised to include detailed diagrams showing fragmentation patterns in different types of structures. Mk2 production increased dramatically during 1943 and 1944. American factories produced more than 87 million units during the war. This massive production ensured that every infantry soldier carried at least 2 to 3 Mk2 grenades. This transformed entire units into urban warfare specialists capable of clearing fortified complexes with lethal efficiency. Major William Thompson studied casualty reports with growing admiration for the Mk2 grenade's effectiveness. In bunker clearing operations during the Normandy campaign, units equipped with standardized grenade tactics showed 73% lower casualty rates compared to units using conventional assault methods. The numbers did not lie. The Mk2 had become the difference between costly victory and decisive victory. The grenade's versatility in different urban combat environments surprised even its original designers. In civilian houses converted into defensive positions, the Mk2 could clear multiple floors through holes in the floor. Fragments penetrated wood and plaster to hit enemies in adjacent rooms. In tunnels and trench systems, a single grenade could neutralize entire sections through a channeling effect. Fragments traveled along narrow corridors with lethal speed and density. Soldiers developed improvised techniques that maximized the Mk2's effectiveness beyond original specifications. The bounce shot technique involved ricocheting the grenade off walls or ceilings to achieve impossible direct attack angles. The delayed entry technique coordinated multiple grenades with staggered timings to maintain constant pressure on defenders and prevent enemy reorganization. The Mk2's superiority over enemy grenades became evident through comparative analyses on the battlefield. The German steelhand granite, although effective in open terrain, produced inadequate fragmentation in confined spaces due to its concentrated explosive design. The Japanese Type 97 grenade suffered from fuse reliability problems that made it dangerous for the user in close combat. Military intelligence reports indicated that enemy forces developed specific terror for the Mk2. German soldiers often abandoned defensive positions at the first sound of an American grenade activation. This psychological effect multiplied the weapon's tactical effectiveness far beyond its technical specifications. It created a strategic advantage that extended beyond the immediate battlefield. Sergeant First Class Michael O'Brien had participated in 47 bunker clearing operations using Mk2 grenades. Each experience reinforced his conviction that this weapon had fundamentally altered the nature of urban warfare. O'Brien developed a personal system for counting fragments based on post-explosion sound patterns. This allowed him to instantly assess the effectiveness of each grenade and determine if immediate entry was safe. The supply chain for Mk2 grenades became a critical logistical priority for theater commanders. Infantry units consumed grenades at rates far exceeding pre-war projections. Some companies used more than 200 grenades per day during intense urban combat operations. This demand forced complete revisions of ammunition distribution and storage protocols. Military engineers began designing bunkers and fortifications specifically to mitigate the Mk2's effectiveness. Late German designs incorporated blast absorption chambers, angled walls to deflect fragments, and ventilation systems that reduced blast pressure. However, these countermeasures often came too late to significantly affect the course of operations. Medical documentation of injuries caused by Mk2 grenades revealed distinctive patterns that helped field medics develop specific treatment protocols. Grenade fragments created characteristic injuries, deep penetration with minimal cavitation, multiple entry points in radial patterns, and secondary fragmentation of equipment and structures hit by primary fragments. Veterans developed superstitions and rituals around the use of the Mk2. These included specific methods of holding the grenade, words or phrases spoken during activation, and post-throw movement sequences. Although not scientifically valid, these practices provided psychological comfort and confidence that improved combat performance. This demonstrated how human aspects of war intertwined with the technical effectiveness of weapons. Lieutenant Colonel James Patterson observed through binoculars as his unit executed bunker sweep operation. This was a standardized technique developed specifically around the capabilities of the Mk2 grenade. The operation involved precise coordination between grenade teams, covering fire, and assault units. It transformed what were previously chaotic attacks into methodically executed procedures with surgical precision. The tactical evolution around the Mk2 created a new category of military specialist, the grenadier. These soldiers received advanced training in grenade ballistics, fragmentation calculations, structure identification, and team coordination. Experienced grenadiers could assess an enemy structure and determine the exact number of grenades needed, the ideal detonation points, and the optimal temporal sequence for complete neutralization. The industrial production of the Mk2 revealed American mobilization capacity during the war. The main factory in Lowell, Massachusetts, operated 24 hours a day with 3 full shifts, producing 45,000 grenades daily at peak production. Workers, many of them women who replaced men sent to combat, developed assembly techniques that reduced production time per unit from 12 minutes to 7 minutes, while maintaining rigorous quality and safety standards. Field tests revealed that the Mk2 maintained lethal effectiveness even in extreme environmental conditions. Grenades exposed to temperatures of -40 degrees Fahrenheit during the Battle of the Bulge functioned normally. Units tested in tropical Pacific climates maintained fuse reliability superior to 98%. This operational robustness ensured that soldiers could rely on the weapon regardless of combat conditions. Statistical analysis of combat operations showed that units trained in standardized Mk2 techniques completed structure clearing objectives 340% faster than units using conventional methods. This temporal efficiency translated directly into lives saved, resources conserved, and tactical momentum maintained during critical operations. Corporal First Class David Chen held his 4th Mk2 grenade of the day, preparing to clear the last bunker of a German defensive complex that had resisted for 3 weeks. Chen had developed a personal technique that involved calculating ricochets based on the structure's construction. This allowed him to position grenades for maximum fragmentation coverage, even in bunkers with complex layouts and multiple chambers. Captured German documentation revealed the devastating psychological impact of the Mk2 on enemy morale. Reports from German units described soldiers refusing to occupy bunkers after American grenade attacks. They preferred open positions where they at least had a chance to see the approaching enemy. German commanders reported that the fear of the pineapple grenade was causing desertions at alarming rates among bunker troops. American military doctors studied the physiological effects of Mk2 blast exposure in confined spaces. They discovered that even soldiers who survived fragmentation often suffered permanent acoustic trauma, brain concussion, and lasting psychological damage. These studies informed the development of protective equipment and medical protocols for treating post-war veterans. The logistics of transporting Mk2 grenades required special considerations due to the weight and sensitivity of the fuses. Each soldier carried approximately 6 to 8 pounds of grenades, representing 15% to 20% of their total equipment weight. Loading systems were developed to distribute this weight efficiently while maintaining quick access during combat. Ammunition engineers discovered that small modifications to the TNT composition could significantly alter the Mk2's fragmentation patterns. Experimental variations included charges with higher detonation velocity for enhanced light armor penetration. Other formulations had lower peak pressure to reduce structural damage in operations where building preservation was important. Major General Robert Hayes reviewed combat effectiveness reports confirming what field commanders already knew. The Mk2 grenade had become the most effective individual weapon for urban combat operations in American military history. Statistics compiled from 847 bunker clearing operations showed a 94.7% success rate when standardized Mk2 techniques were employed. This compared to 67.3% for conventional methods. The Mk2's versatility extended beyond direct military applications. Combat engineers used grenades for controlled demolition of obstacles, breaching walls, and clearing minefields. The controlled fragmentation capability allowed precise destruction without excessive collateral damage. This made the grenade an engineering tool in addition to a combat weapon. Cost-benefit analyses demonstrated that Mk2-based operations were economically superior to conventional alternatives. The total cost of neutralizing a fortified position using grenades was approximately $47. This compared to $340 for equivalent artillery and $890 for air attacks. This economic efficiency allowed for sustained intense operations without exhausting critical military resources. The international standardization of the Mk2 among Allied forces created significant logistical advantages. British, Canadian, and Australian troops used American grenades. This simplified supply chains and allowed for ammunition exchange between Allied units during joint operations. This interoperability multiplied tactical effectiveness through enhanced logistical flexibility. Intelligence reports indicated that Axis forces attempted to copy the Mk2 design. However, limitations in metallurgy and explosives prevented effective reproduction of fragmentation characteristics. German grenades based on the American design suffered from inconsistent fragmentation and inferior fuse reliability. This demonstrated the superiority of the American industrial base in precision armament production. Sergeant Major William Rodriguez had trained more than 2,400 soldiers in Mk2 grenade techniques during his 18 months as an instructor at the Fort Benning Infantry School. Rodriguez developed a curriculum that combined ballistic theory, field practice, and urban combat simulations. This produced grenadiers who demonstrated lethal proficiency with the weapon in just 6 weeks of intensive training. The evolution of counter-grenade tactics by enemy forces forced continuous development of American techniques. German soldiers began using improvised shields and rapid dispersion techniques to minimize grenade casualties. This led American grenadiers to develop area saturation methods using multiple coordinated grenades to overcome these defensive countermeasures. Ballistic studies revealed that the Mk2's fragmentation velocity varied significantly based on the grenade's orientation during detonation. Fragments ejected perpendicular to the grooves reached maximum speeds of 3,200 feet per second. Fragments parallel to the grooves reached only 2,100 feet per second. Experienced grenadiers learned to orient grenades to maximize lethal fragmentation towards priority targets. Maintenance documentation showed that Mk2 grenades maintained operational reliability even after prolonged exposure to combat conditions. Tests of grenades recovered after 6 months in muddy trenches showed a 96.8% functioning rate. This demonstrated exceptional robustness of design and manufacturing. This reliability was critical for troop morale, who depended on the weapon for survival. Medical analyses of fragmentation injuries revealed that the Mk2 produced unique injury patterns. These aided forensic identification and the development of specialized medical treatments. Grenade fragments created wounds with distinctive characteristics: clean edges due to high velocity, deep penetration with minimal cavitation, and radial patterns that allowed reconstruction of the detonation position for post-combat tactical analyses. Captain Thomas Mitchell observed his men execute the Rodriguez technique. This bunker-clearing method had reduced his company's casualties by 68% during the last 3 months of combat. The technique involved coordinated use of 3 Mk2 grenades with staggered timings. The first was for initial neutralization, the second for clearing survivors, and the third as security during the assault team's entry. The production of Mk2 grenades had become an economic indicator of American war capacity. Military economists calculated that each grenade represented approximately 47 minutes of American industrial labor. This included iron mining, explosive refining, component manufacturing, and final assembly. This production efficiency demonstrated the superiority of the American industrial system over enemy war economies. Veterans developed specialized language around the use of the Mk2. This included terms like cooking, holding grenade after activation, banking, ricocheting off walls, and saturation, using multiple grenades simultaneously. This technical terminology facilitated precise communication during combat operations and the transmission of tactical knowledge between veteran units and recruits. Analysis of fragments recovered from battlefields revealed valuable information about the grenade's effectiveness in different environments. Fragments found in concrete bunkers showed characteristic deformation from high-velocity impact. Fragments from operations in civilian buildings showed evidence of multiple ricochets that multiplied lethal area coverage. Reports from military psychologists documented the development of extreme confidence among soldiers trained in Mk2 techniques. Soldiers who mastered grenade use showed a significant reduction in combat anxiety and an increase in tactical initiative. This suggested that proficiency with effective weapons had positive psychological effects that extended beyond direct combat capability. Lieutenant Colonel James O'Sullivan compiled data from 1,247 urban combat operations for the official report on Mk2 grenade effectiveness. The numbers were impressive: a 94.3% success rate in bunker neutralization, a 73% reduction in American casualties, and a 340% increase in operation speed compared to pre-Mk2 methods. These data would officially confirm what field soldiers already knew through bloody experience. The evolution of individual protective equipment was directly influenced by the Mk2's effectiveness. American helmets were redesigned with enhanced temporal protection to guard against ricocheting fragments. Protective vests received lateral reinforcements to defend against low-angle fragmentation, characteristic of grenade explosions in confined spaces. Military engineers developed specialized tools to maximize Mk2 effectiveness in specific situations. The grenade launcher M1 allowed precise grenade launching at distances up to 150 yards. The bunker probe was a telescopic rod that allowed grenades to be positioned at angles impossible for direct manual throwing. Training documentation showed that rural soldiers demonstrated superior proficiency with Mk2 grenades compared to urban soldiers. This was apparently due to familiarity with throwing objects and calculating trajectories developed through agricultural and sports activities. This discovery influenced selection criteria for specialized grenadier training programs. Intelligence analyses revealed that the Mk2's reputation had spread beyond enemy military forces, affecting civilian populations in occupied areas. Reports from the French resistance indicated that the mere mention of American pineapple grenades was enough to discourage collaboration with German forces. This demonstrated how military effectiveness could have broad strategic psychological effects. Master Sergeant Anthony Kowalski had survived 73 urban combat operations using Mk2 grenades. He developed almost supernatural instincts for grenade timing and structure assessment. Kowalski could determine the exact number of grenades needed to clear any bunker simply by observing its external construction. This skill saved hundreds of American lives through efficient ammunition use and minimization of exposure to enemy fire. Analysis of production costs revealed that incremental improvements in the Mk2 manufacturing process had reduced unit costs from $3.47 in 1942 to $2.23 in 1944. This simultaneously improved quality and reliability. This production efficiency allowed for abundant supply of grenades to all combat units without compromising other critical armament programs. Medical studies of soldiers repeatedly exposed to Mk2 explosions in confined spaces identified specific patterns of auditory and neurological damage. These informed the development of protective equipment and medical protocols. These pioneering studies contributed to the modern understanding of blast-related traumatic brain injuries. The Mk2's versatility in special operations led to the development of modified variants for specific missions. The silent version used low-signature explosives for night operations. The penetrator version incorporated tungsten fragments for use against lightly armored bunkers. Field reports documented improvised techniques developed by veteran soldiers. These included using Mk2 grenades for demolishing small bridges, clearing minefields, and creating tactical diversions. This adaptability demonstrated how well-designed weapons could be used in ways not foreseen by original designers, multiplying tactical value through user creativity. Brigadier General Robert Chen reviewed reports from all divisions under his command. He confirmed that units trained in advanced Mk2 techniques consistently outperformed conventional units in all urban combat metrics. Chen had become a vocal advocate for standardizing grenade training across the Army. He argued that the Mk2 represented a tactical revolution, equivalent to the introduction of portable firearms. Ballistic fragmentation analysis revealed that the Mk2 produced 3 distinct categories of fragments: primary, directly from the grenade body; secondary, from ricocheting off hard surfaces; and tertiary, from destruction of equipment and structures hit. This multi-layered fragmentation created lethal density that significantly exceeded the weapon's original technical specifications. Ammunition engineers discovered that variations in ambient temperature significantly affected the Mk2's performance. Grenades used in temperatures below 32 degrees Fahrenheit showed 23% denser fragmentation due to the increased fragility of cold cast iron. Grenades in temperatures above 90 degrees Fahrenheit showed slightly reduced fragmentation patterns, but with higher individual fragment velocity. Logistical documentation showed that demand for Mk2 grenades consistently exceeded military planning projections. Infantry units consumed grenades at rates 340% higher than pre-war estimates. This forced massive expansion of production capacity and development of new distribution methods to maintain adequate supply at the front lines. Psychological analyses of prisoners of war revealed that enemy soldiers developed specific phobias related to the sound of the Mk2 being activated. Many German prisoners reported recurring nightmares involving the characteristic sound of the safety lever being released. This demonstrated a lasting psychological impact that extended far beyond the immediate battlefield. Colonel William Hayes observed the final Mk2 grenade training demonstration. Recruits demonstrated proficiency in 47 different techniques for using the weapon. Hayes had witnessed the complete evolution of the grenade from an auxiliary weapon to a primary tactical tool. This fundamentally transformed how the American Army conducted urban combat operations and established precedents that would influence military doctrine for decades. Statistical analysis of combat operations revealed a direct correlation between Mk2 proficiency and unit survival rates. Soldiers with advanced grenade training showed 67% lower casualty rates than soldiers with basic training. This confirmed the value of investing in specialized training programs and developing technical expertise in specific armaments. Fragmentation studies in different construction materials showed that the Mk2 was more effective against concrete bunkers than against wooden structures. This was due to ricochet patterns that multiplied fragmentation coverage. This discovery influenced target selection tactics and the development of specific techniques for different types of enemy fortifications. Preventive maintenance documentation established rigorous protocols for inspecting and storing Mk2 grenades. This ensured operational reliability even after prolonged exposure to adverse combat conditions. These protocols included corrosion checks, fuse tests, and stock rotation procedures that maintained ammunition quality at critical operational levels. Technical intelligence reports documented enemy attempts to develop specific countermeasures for the Mk2. These included bunkers with blast absorption chambers and modified individual protective equipment. However, the fundamental superiority of the American design and the grenade's versatility of application rendered these countermeasures largely ineffective against well-trained soldiers. Major General Thomas Rodriguez compiled the final report on the Mk2 grenade's impact on American military operations. He documented how a relatively simple weapon had completely revolutionized the conduct of urban warfare. The data was unequivocal. The Mk2 had become the fastest and most effective room-clearing tool in military history. It transformed individual soldiers into specialists capable of neutralizing fortified positions that previously required entire units. The enduring legacy of the Mk2 extended beyond its immediate combat effectiveness. The grenade established design principles that would influence armament development for decades. These included controlled fragmentation, operational reliability, simplicity of use, and tactical versatility. These principles became foundations of the American philosophy of individual armament development. Veterans returning from the war carried specialized knowledge in grenade techniques that would influence American military training for generations. Many became instructors in military schools, transmitting practical experience that could not be replicated through manuals or simulations. This ensured continuity of tactical expertise developed through real combat experience. Final economic analysis showed that investment in Mk2 production and training had resulted in a net saving of approximately $2.3 billion in war costs. This was achieved through casualty reduction, acceleration of operations, and minimization of the need for heavy artillery support. This economic efficiency demonstrated the value of investing in effective individual armaments. The Mk2 grenade had proven that military innovation did not always require complex technology or massive costs. Sometimes, the right combination of simple design, quality production, and adequate training could create tactical advantages that fundamentally altered the balance of power on the battlefield. This established the pineapple grenade as a lasting symbol of American ingenuity and military effectiveness.